Okay, we're getting into design tables now, and he had me click on these dimensions and rename it here to diameter and here to wall, from its default value. So, okay, now we're going to specify the length of this tube we've created. Okay, that's not where you do it. Do it here by clicking on the 12-inch dimension. Or right click on the 12-inch dimension, rather. So say we had our D1, so I put links in there. Just like
we
that.
also want the configuration name and description in the tables.
Okay, I went to the, properties. And change that, so making a new category, materials.
Now right click on the 316 annealed stainless steel bar material and then select copy.
Oh. Alright, so we'll rename this. Okay, now we're going to go create a table, so we'll insert tables and design table. And, here we can import, tables from Excel or whatnot, but we're just going to use the default generated table that it creates. Okay, so we basically select all these and hit OK. Man, that's tiny. Okay, I went and added these two entries, added this data here, and by the way, when you double left click on this, it resizes the column, so that was kind of cool. Because this is just an Excel spreadsheet, as it turns out, so glad I have Excel installed. Okay, now I just click out here and it closes the table. And it tells you it generated the configurations. So, which I guess you can see here, the first tube and the second tube, those are the two I typed in. That's new configurations. Okay, so if I want to go look at the table again, I guess this is how you do it, I don't know. Maybe not. Oh, wait, a table, yeah. You can see I just wanted to edit the damn table. I wanted to add some more properties to it. But you can see, I changed the wall thickness here and the length property. As you can see by these column titles, and again, this is just the diameter property. So, but now, if you want to go apply these changes, you get a double click on it. so it gives you 3 different. Okay. Yeah, it's supposed to ask you that. So you can see we got 3 different types here based on that table. Okay, now I'm editing the table again, but we're going to add these 2 parameters, and we're going to add this one manually later. So alright, now I'm going to show you this. I'm sure this will work in Excel too. You know, if you just, you know, when the cursor goes like that, you double click it, it auto sizes it to the text. Okay, and he had me move the description over here. It's just Excel, so, and we manually added this part number. Clicking, you know, $sign part number, and we enter these part numbers.
If you try to scroll down, a message will pop up saying your changes will be applied to the table the next time you edit it. Click OK, and then change the BOM setting.
Yeah, we're changing these, you know, manually editing these values, you know, in the second part number. And we're going to see how it's reflected in the table later. I'm going to change this to use configuration name, and that dialog box popped up again. Okay, now we're going to do the same thing here.
And then change the part number in the BOM. Once you've done that, apply your changes. Now let's see how this affected the table. Right-click on Design Table, and then edit the table. We've modified the names of the configuration, so we have to select them. Hold the Control key down and select the configuration names. And then click OK. Now the part numbers are shown in the configuration cells, and the part number cells have the value $C. This is the parameter variable for configuration names. So this variable sets the part number to the configuration name. You'll learn more about the names of parameter variables in the next lesson.
Okay, we're going to go into the help. You know, which is different than his, but oh, shit. Yeah, I think it's actually here, but for some, you know, he's on a web search, I think, you know, is why his is working differently. But this is what we're looking for. I don't know why I couldn't search for it. Yeah, but like I said, this gives you all the different parameters of the table, so, you know, it's good reference. Okay, I'm going to make some changes here. We're going to put $. C in that value for some reason. Change this to 400. God damn it. Change this to 3/4 -125 -76 or SS tube. Change this to 0.75. Change this to 0.125. Change this to 76. Now, the rule on this table is that, okay, these are basically contiguous, right? So, you know, you can't allow any spaces in this between these numbers or they won't count. Now, but the thing is that you can drive any of these figures with equations outside of it. So I can go enter equations like that, for example, and it won't fuck up the table. So I could actually drive these dimensions with an equation outside of this if I wanted to, just like I drove this with data from one of these cells. So, you know, apparently it's just like a spreadsheet in that sense. So now I don't know what this C thing is for. It's something to do with automatically finding stuff. He's going to show that, what that means. What the fuck is going on with this thing? And when I close the table, you know, it generated a configuration, so I don't know if you got that. And let's click OK on this because it's not using the default entry anymore. And here's the results of it. So 3/4 inch tube now.
What we got here is grandma's.
Okay, we're making a custom table for this lid part. But you know, you can go to like a sketch,
and then click it.
select this.
This adds the dimension name to the cell and adds the value below. It also acts. Another problem you'll have when you don't rename dimensions is it will be difficult to know what the dimensions represent.
Because the cursor automatically went to the next column after I clicked that first one. So I was able to click this one and it added it automatically too, so it just keeps going over to the right.
Apply your changes.
I'm going to rename these to length.
Now click the 5-inch dimension and then change the name to width.
Oops.
Also notice that the dimensions are pink. This is SolidWorks' way of letting you know that the dimensions are used in a design table.
There you go.
Now that we've modified the names of the dimensions, close the sketch and then edit the table. The default configuration is listed, and notice that it's still listed in the tree. You can see that it's not part of the table because of the configuration symbol in front of it. The only configuration that's in the table is the 5x8 lid, and it has the Excel symbol in front of it. The default configuration was already in the file when we created the table, and we didn't add it to the table, so it wasn't added. And we're not going to add it now. If you look in the parameters window, you can see a few more parameters. We could add the tolerances for the length and width dimensions, but we're not going to. Whenever you see new parameters in the list, try to notice the syntax of the parameters. This will help you later when you need to use them. Now let's add some configurations. In cell A4, enter 900-001, add a 900-002 configuration, and add a 900-003 configuration. Make the description for 900-001 5x5 lid. The next configuration is a 6x9 lid And the last configuration is 9 by 12. The length of this configuration is 5 inches. This configuration is 9 inches. And the last one is 12 inches. Set the width of this configuration to 5 inches. This configuration is 6. We're adding 3 new configurations, so click OK. Now you can click through the configurations. We're not going to use the default configuration, so delete it. Right click on it and then select delete. In the next lesson, you'll learn how to suppress and unsuppress features of the lid using the design table.
Okay, we're going to go add a configuration to the table. So we're going to copy these there, like so. This is more of a lesson about things I didn't know about Excel. You know, if you just grab this grip, you know, it'll automatically create a copy, you know, in cells like that. It's kind of neat. Okay, now I got that up there, and if you go double click, you know, it'll add a default kind of configuration to it, which is a suppression operation. And that's interesting too. This little help thing pops up when you if you rebuild the table, accidentally click Control S or whatnot, and had to rebuild the table or whatever, the document. But you know, apparently it gives you some little pop-up help here. I didn't notice that happening before, so it's interesting. Alright, so you know, we suppressed the cell operation in some of these. You know, so you can see a couple of those were the shell operation was suppressed, and a couple there weren't. So we can also add them graphically just by double clicking a feature that we want to suppress or whatever. And you go change this to U. And use that method to drag copy it, and go ahead and resize the column. You want to suppress it on the biggest lid. So you know, we'll click out here, and you know, you can see, you know, the biggest one is just a blank plank of wood. Now, if we were to delete this column, it wouldn't change the state of suppression because it's changed it, you know, in the other, you know, dialogues and properties areas. So, you know, so just keep that in mind. You can't delete that and have these properties go back to the way they were before we edited them. Oh, and by the way, too, you know, if we hadn't, you know, which we kind of didn't for this part, we didn't go in and start with like editing the names of the dimensions. And when you do that and you go create a new table, you know, by inserting the table, it'll basically have a list of every dimension in the part. So, which, you know, again, in a big part with a lot of dimensions in it, that could have like hundreds of items in it. So that's why it's best to name it, at least one of the dimensions first, because it looks at whether a dimension has a name to it that's not default. A default name, and then it'll actually just limit, you know, what dimensions it's choosing. That's why it's kind of better before you create a table to usually go in and, you know, name the dimensions first that you want to be in your table, and then you can add them easier and have it just auto create the table. So in any event, you know, if you wanted to actually delete one of these columns, it's best to change the state of it first and then delete the column, you know, if you don't want a feature in your table for some reason. Okay, another thing you can do, you know, is go edit design table, new window. And shit. Okay. Anyway, that brings it up in Excel. So, although everything's a little, you know, a little shrunk down here, but okay, then you can basically highlight two cells and do that, and it'll actually sequentially add two more, which is kind of cool. So even though there's no auto update part number, I don't know if that'll work in like a regular spreadsheet or not, but no, apparently it doesn't. So it must be something specific to that their little deal. Oh man, this is really cool. Okay, so we just created these two new configurations, right? I'm glad I typed it in exactly like you did. Okay, so if we highlight these and drag this down, you can see the little number, 400-030 or etc. On the right of my cursor. If you drag it there and release, you can see it picked up on the sequence, of all these numbers in my little description here, and it changed the diameter to match it. So it was good at, kind of wish Excel did that. I mean, I guess this is a macro they have in here or something that does this. I don't know. But, that's quite cool to be able to add, this many different part numbers. So we've automatically added all these modifications that I have to type all this crap in. That's awesome.
Yes, if you would like to see the full list.
Okay, so when I close this sheet now, it automatically generates all these configurations. Okay, it says there are more configurations. Would you like to see them? And I don't want to see them, so I know they're there. It only goes to 27, so click no, and then we got all these shitloads of configurations in here already. Automatically done. That's why parametric CAD systems are so great. That's pretty awesome if you're creating a family of parts. So that was simple and quick. And apparently, even though we created all these different part configurations, hold on. Now you can see that the tubes file, is actually quite small, but apparently, for her to activate all the different tubes, it would have been a huge, like 3 megabyte file. I mean, which, this is for a simple part, so imagine what a complex part would be. But I don't think it matters if you view it, because they're not all activated. So there's only one instance active at any time. So but see what I did? I did activate several of them, and you can kind of see the ones that have been activated. So now our file size has grown to 1.3 megabytes. So it's good not to, activate these things unless you need to activate them. So, because like I said, the more you activate, the bigger your file grows. Okay, now, we're going to go and, open our table in Excel again, and we're going to take all the configurations and we're going to cut and paste them outside of this parameter here. Okay, now there are effectively no configurations in the table, because remember the table, is closely related to where these description columns are. Anyway, we're going to take, this and grab it over here. So the table is still in here, but when we go back to SolidWorks, basically says it's going to delete all these configurations. So, we're back to, not having much in the way of configurations anymore. Not sure why we still have this one. Okay, now I brought the design table back up, and the whole point to doing this is we're going to try to reduce the size of that file and generate these, more like from a reference, I believe. So, okay, so you collect this, and remember this is all in Excel, so you might have to go here, but go to validation. And change this to list.
The selection icon, and then drag a window over the part numbers.
And do this.
Now close the selection window.
Close the selection window.
Confirm that both of these options are checked, and then click OK. Now scroll up to the top of the worksheet.
Okay, now if we scroll up to this, you see we got this little checkbox. Okay, so now we can actually go select a configuration from it. So that's kind of neat. Now I have you note in our little table, it's no longer doing the references that it was doing, although this is still changed. But at any rate, we're supposed to go put a Vlookup function here. With A3, comma, our entire table here, and comma 2. Okay, so I went and applied the VLOOKUP to, I didn't do it the same way he was doing it. I was trying to be clever and, and put absolute references in there so I can copy and paste it, but, his way would have been just as good because I still had to go edit this column number anyway. That's the column number in the table. So this way, anyway, if we go choose a given part, you can see that all of our reference stuff changes. But the diameters still have not updated. No, I mean I'm fucked up now. The length is still changing, but we just set the diameters are all the same. So I mean the table is updated just fine. So anyway, let's close this. Okay. Alright, so what I did was, so I saved this as a new part number, 400-0001. He told me to delete this, but I'm not going to do it. But now we're going to go edit the table. Select a new configuration. Okay, and this should be updated. Okay, so the whole point is we're trying to actually save, because it's apparently saving these configurations, so, we'll activate the one we just opened, and then we can delete these two configurations. And then we can go, save as. .0002. So we can create a family of parts this way using a parametric table without the main part table being super large, I think is the whole point to it. So it's a way of creating separate representations. And I don't know how necessary that is, because again, unless you activate those representations, they don't, like I showed you earlier, they don't fill up your memory until you actually click on them. So it seems to me like, having the original table would be best, because then you got like a parametric parts list. So you don't have to have like 50 different tables on your hard drive. You can just have one table. But this is a way of at least separating it out into parts. So anyway, but the problem is that once you do this, they're no longer related to each other in any way, shape, or form. So again, that's why I would tend to not want to do this in practice if I was trying to create a library of parts, because it's better to have them all, like we originally had it before I went and Mickey'd with the table, or I would say even like we have it now, where it's all parametrically generated, but still, it may be better to have them all as like we originally had them, to where you can go and actually edit it and actually, make significant changes to some of the part numbers while still keeping the, the relationship, parent-child relationship and the inheritance and all that crap. Although these aren't children, these are alternative, these are all parent relationships, that, so they weren't really necessarily related, but like we saw before, I mean, they can be. So, just not in the parent-child way, but they can still, all have similar properties and distinguishing properties too. So, anyway, it just depends on what you're doing. Okay, now we're going to be creating a raw Excel table, and we're going to import it. Okay, I first name that, but on cell A2 I can change the name of the field to family. So, okay, I'm typing this height at sketch 1. So press enter, it creates a internet link, so you just press undo, to undo that. So that's how to get rid of that. It seems like something's wrong with my properties. I mean, this is not working right. I don't know why that is. Okay, so since we're making a cube, have to do that. Okay, so we created this table, as you saw, and created this cube, and I've already renamed all the dimensions.
Now select from File.
Okay, design table. Oh, damn it. Okay, yeah, from table, click the browse button. Now, I already added the cubes worksheet in here that we created. And we'll click the link to file option, and also it'll link it to the file so we can edit it without SolidWorks being open. Okay, now let's click OK, and that imported the design table. So click outside of it. Yep. Following configurations. You know, the funny thing is I really didn't have to do anything special with the design table, which is interesting. So it makes me wonder if that thing really does work. Let's go see what configurations it created. A 2-inch, 3-inch, and a 1-inch cube. Perfect. Now let's go to Excel and see if that trick still works. Yeah, I mean it does. I mean that's apparently a feature of Excel. It just wasn't working properly. Oops. Jesus. Hold on. Let me see, I forgot to edit this. Okay. Alright. Apparently it's not working anymore. That sucks. Good. It should update, you know. I guess it's not picking up on that change in number. I guess because it's not on the end, but it is changing these numbers and all these numbers. Okay. Anyway, let me save the table. I don't know if I have to re-import it or not. Alright, anyway, if we're to go, like, delete the design table, then it'll just fix everything that we have here. It won't delete the configurations, just the table. But, you know, like I said here, you know, it's a little confused. So, even though I made all those changes, you know, apparently it's changed the nature of the table in some fashion. So, I don't know if you gotta close the damn thing or what. Yeah, apparently, you know, I don't know that it does you much good, you know, to create a table like that, because apparently it's working on a different copy of it or some shit now. So, I'm not sure. At any rate, I'm going to close this. I still edit the table this way. Side of it. Alright. And then it works. Anyway. Interesting. Okay, I've added a hole to one of our cubes here, but I've not named any of the dimensions, so And none of this shit's working. Okay, apparently, you know, I had to select the goddamn cube to get it to do this. What a bunch of fucking bullshit. You know, just does not work. You know, like his did, apparently. You know, because if I just do display dimensions, well, now it works. You know, again, it's another one of those things where at first it doesn't work, okay, and now it fucking works. You know, unbelievable. Unbelievable. You know, how many times I have to toy with this to get it to fucking work right. So, I mean, this is just fucking bullshit. This fucking program's got fucking bugs or some bullshit in it. Okay, now all the pink dimensions, of course, are, you know, ones that are in our table, and I could, you know, go hide all dimensions for a particular feature if I wanted. Oops. Okay, first I'm a little confused why this isn't showing up, but I don't think it's dimensions is why. Okay. Alright, so at any rate, we can go to view and have it select dimension name so you can see our names and the dimension. Alright, now I can like double click one of these and I can actually change the name here. Okay, and it'll take care of it. That's easier to add the name there. And do the same there, change it to diameter, so you can see it updates over here automatically. Now we're going to go to Tools, Equations.
This opens the Equations dialog box with the equation view active. Global variables are variables you can add that aren't defined by a dimension. For example, you can enter the density of a material and use it in an equation to control feature dimensions. You can suppress features, and usually this is controlled by an if statement, so later in the course I'll show you how to do this. For now, we're interested in writing an equation that controls the location and size of the hole. Click in the cell. This has the name of the dimension and adds an equal sign in the equation cell. The diameter of the hole will be 1/4 the width of the cube, so type 0.25 space asterisk space. The asterisk is a multiplication symbol which is commonly used in spreadsheet software like Excel. Now click the width dimension. When you've written a valid equation, you can see the check mark. You can add more to the equation, but this is all you need for this equation. Click the check, and now we're going to write an equation for the offset of the hole. Click in the cell, and then select the offset dimension. The offset is going to be 1/4 the height, so enter 0.25 space asterisk space, and then click the height dimension. You don't have to add the spaces, but it makes it easier to read. Click the green check, and then click OK to create the equations. You can easily see which dimensions are driven by equations because they have the capital sigma in front of the name. Now let's see how equations affected our configurations. Activate Cube 2. And as you can see, the equations drive the size and location of the hole. In fact, they drive the whole feature in all three configurations.
Okay.
Now we're going to apply a unique
Anyway, I had to unsuppress the damn feature. I forgot how to do it in mass. I don't know how to pull up that feature table, you know, anyway. Okay, I found out. It's, you know, if you click on the feature and you hit, you know, configure feature, that's how you get there, you know. So we don't want to suppress it in any of these. Okay. So now we can look at our various configurations and remember our equation. So, you know, you can see the hole size get progressively smaller, but still, you know, maintain a driven location. So, anyway, and of course I could go, you know, hide the names now. Dimension names, but we still have our little equation symbol, you know, by the dimensions, and of course I can go to annotations and, you know, hit show feature dimensions so everything's nice and hidden. Alright, that pretty much completes it for the TEDCF whatever videos, thank God. So anyway,